Okay, I'm going to try to do one, maybe two of these optimization problems. This is a problem from the book. Find the points on the ellipse 4x squared plus y squared equals 4. That's farthest from the point 1, 0. I think part of the problem is just getting a picture of this. Sketching a graph of an ellipse. Ellipse is an oval shape. If you let x equal 0, it's just simply plot it by finding the intercepts. The y values are going to be plus or minus 2. So if x is 0, I'm going to have y values of positive 2 and negative 2. Conversely, if I let y be 0, my x values are going to be plus or minus 1. We plot the points on an ellipse simply like we would any other function. Plug in an x and see what y has to be. You get this oval shape. This is what an ellipse is mathematically. And we're looking for points that are farthest from this, 1.0 or 1 comma 0. Where's the farthest point? All right. So is it here, maybe across there? That would be an easy 2 units, but it looks like it's definitely farther to go 1 unit over and 1 unit up. So I'm thinking that a point about here is going to be the farthest, somewhere, if you can imagine inflating a circle, then probably a symmetric point down there. So that's a reasonable guess, all right? But how do we do it? Well, we need to write an equation for this mystery point. This mystery point has coordinates x, y, okay? Again, just think about what's allowed to float and what's fixed. This point is fixed, but any point along here are going to be x and y values that satisfy this equation, okay? So, what is this distance right here? Let's start with that equation. Well, the distance is just going to come from the distance formula, which is the square root of, when I subtract the x's, it's 1 minus x squared, plus when I subtract the y's is 0 minus y squared, okay? Well, I can clean that up a little bit by just saying it's going to be the square root of 1 minus x squared plus y squared, okay? That's going to be the thing that I want to minimize. Well, what I need to do is take this original formula and then substitute it in to get rid of y. So how do I solve this for y? I get y squared equals 4 minus 4x squared. Now, really clever mathematician would say, oh look, this is y squared and that's y squared. I can just substitute this in place of that. But I doubt that any of you guys would think of it. I probably wouldn't think of it until I realized that y then is equal to the square root of 4 minus 4x squared. And then when I substitute this in exactly right there and I square it again, I'll realize that of course the squaring the square root gets rid of that. So this becomes then the square root of 1 minus x squared plus, and then 4 minus x squared altogether. 4 minus x squared, okay? So that's the combined equations that I need to optimize. All right, well, what do? I'm going to take the derivative of this. I think it would make sense to, whoops, I realize now that that squared sign is on the outside. I think it would make sense to combine some like terms. So this is going to be equal to, when I FOIL this out, 1 minus 2x plus x squared plus 4, and then minus x squared, 4x squared. Boy, I'm sorry, I'm being a little sloppy. That's a 4 minus 4x squared. So this then, positive and a minus will give me, and then a 4 and a 1 combined to make 5. So I should double underline that. That's 5 minus 2x and then minus 3x squared, because positive 1 and a minus 4 give me that. All right, well, I'm going to take the derivative of this. I think it's easier to express it in exponential form. 5 minus 2x minus 3x squared to the 1/2. So that 1/2 comes out when I take the distance. I'm going to call it d of x. That's my function I'm taking and finding the derivative. And then I subtract 1, and then I have to take the derivative of the inside. So I get 1/2. Then 5 minus 2x minus 3x squared to the minus 1/2 times, what's the derivative of the inside? Negative 2 minus 6x. Okay? That's my derivative. I'm going to work this way because I'm running out of whiteboard, but I want to set this equal to 0. And this is a minus, so that goes in the denominator. The 1/2 gives me a radical. So I'm going to say 2 in the denominator, then radical 5 minus 2x minus 3x squared. In the numerator goes minus 2 minus 6x. Okay. Well, if you think about it, the only time a fraction is going to be equal to 0 is if the numerator is equal to 0. So that makes it a lot easier. This just drops out. Okay? So I'm just going to save my whiteboard space and say, all right, the only time that numerator is equal to 0 is if I add 2 to both sides and say that 2 equals minus 6x, and then I divide by minus 6. This is getting easier. And so x then is equal to negative 1/3. All right? So in a way that makes sense. This is minus 1 comma 0, so this is a pretty good guess. That's minus 1/3. Now I need to know the y value going up and the y value going down, or does it just say, find the points? So it's going to be minus 1/3, and then if we substitute it in for x, 1/3 squared is 1/9, so this is 4/9 plus y squared equals 4. If I subtract that from both sides, that will get 36/9. When I take away 4 from 36, I'll get 32/9. So the square root of 32/9. So it'll be radical, and I'm just going to leave it 32/9. All right. But once you've found that negative 1/3, you've really cracked it. That's the x value, and plugging it in to find the y value is fairly straightforward. So your other point then will be minus 1/3 comma minus radical 32 over 9, and you could make it radical 32 over 3 because you can take the square root of the top and the bottom. All right? But that's the idea for how you solve one of these problems. You've got the two equations, you substitute into the one you want to maximize, you take the derivative, set that equal to 0, and then solve for your x value, and then go back and find the dimensions or the other coordinates or whatever you need to do. All right.